So the last part is collision between our bricks and our ball sprites. So what we're going to do is we're just going to do the same thing we did with the platform and the ball sprites, and we're going to say pygame.sprite.group collide, except this time we're looking for the brick sprites colliding with the ball sprites. We don't want to kill either of these, so it's going to be a false and a false again. And we are going to make a custom function for this. I'm going to call it brick hit. So remember, this is the callback function. This is what ultimately is going to determine if they hit and what to do with that. So we're going to go up to where we have our other collision here, this platform bounce, and we are going to make a function for the brick hit. Now remember, this function comes in with two argument or two parameters here. The first parameter will be whatever that first group was, which will be a brick. The second one will be a ball. We're going to test this collision. We're going to say just a quick rectangle collision check to see if we should proceed. And that's going to be if the sprite collide rect we just want to look if there's a collision between the brick and the ball. Again, this is like the other one where we'll do a little bit better collision check in a second. But if there is a collision, then we can return true. And if there isn't a collision, then we can return false. And I don't actually need to put an else here, because if it's not true, it'll just return the false anyway. So it's kind of a shorthand way of saving us from writing out else. So we're going to probably do two things here. I think the first thing we need to do is say what happens to a brick when it gets hit. The other thing is what happens to a ball when it gets hit. And we're going to make methods just like we did right here. Now, the platform, really, nothing changes with the platform, but the bricks do change. So let's start with the brick. And we'll say if there is a brick hit, I'm going to make a brick hit method then for brick. So it's different than the function. You could call it something else. I'm just going to be consistent with this, though. Call them all the same thing. So when a brick gets hit, it's going to run this brick hit method, and we're going to give it the ball as a argument here. So let's go ahead and make this method. So let's hop back over to our brick class here, and underneath our update method, we're going to have one more method here called brick hit, and it's got to have self, and we also said it's going to have the ball in here as well. And the reason I'm bringing in the ball is because I think our ball should have some sort of damage counter associated with it. So let's actually go over to our ball and let's say, you know what, if there's an HP value for the brick, then there should be a damage value for the thing attacking the brick, for lack of a better word. So I'm just going to go down to, I'm just going to put it right before we center our rect and say damage the ball does to the brick. And for right now, I'm just going to say it's 1. So self.damage equals 1. So in my ball, I'm just adding this attribute of damage, and that's how many hit points we'll take away from the brick here. So if there is a collision, then we want to make sure that we decrement the HP by however much the damage is, kill the sprite if there's, if it's 0 or below 0, and update the color if it's still there to a different health color. So let's go ahead and just do a little bit more of a precise check here, and we'll say collision is equal to pygame.sprite.collide mask in this case. And then we'll do our self with the ball. So we're seeing if the brick is hitting the ball here. Now, if it does hit the ball, so if there is a collision, if that detects a collision between the two masks there, what we're going to do is we are going to say that the self.hp minus equals the ball.damage. So we're going to take some damage off of that or take some HP off of the brick based on the ball's damage. Now, if the HP ever goes below 0 or equals 0, then our brick is gone. It's gone away. We don't need it anymore. So we'll do a check for that, and we'll do a self dot kill on that and get rid of that brick. Now, if our brick still survives the hit, then it shouldn't be that bright green anymore. We should say, okay, well, let's update the health color to be something else. So in this case, we'll just update it to be whatever the next percentage is, which we'll calculate that automatically. That's how our other method is set up. So let's give this a try and see if it works. So it's working. You'll notice it's striking them multiple times because we don't have any reflection of the ball. So the ball is just staying on top of these for every frame. So it's pretty much killing them right away, which is fine. We'll adjust that in a second, and we're going to do that with the ball collision. We're going to say, hey, the ball can't keep staying on top of these bricks. It's got to reflect. It's got to go the other way. So that should be it for our brick method here. Let's go over to our main.py again, and let's do the same thing with the ball. We'll say, you know what, our ball needs to have some interaction with this brick hit. And we're kind of doing the opposite, I guess. We're saying we'll give the ball the brick then and say, okay, well, what should it do with this brick? So let's go over to ball, and we'll go down to the bottom. This is a big collision method right here, so the platform hit. So we're going to go after that platform hit. We want to make sure we're on the right tab, which I believe is this one right here, and we're just going to make a brick hit method right here. It comes in with self as well as with the brick that it's bouncing off of. So let me just double check and make sure that's in the right spot. I'm just going to follow that line up. It is not in the right spot, so I need to move it back one more. So this is the right spot right here. So now our ball is going to have to reflect when it reaches a brick. So we're going to do the same thing that we did with the other one with the collision. So we'll just say collision is equal to pygame.sprite.collide mask, and we're going to check ourself with the brick. If that's all good, then we can say there was a collision, and we can go forward and start calculating what's going to happen here. Now we're going to look at another delta time. Remember, delta time was the time in milliseconds between frames. We're going to look at delta x and delta y as it relates to collisions. So let's assume I have my ball here, and it's registered a collision with a brick. Now the rectangle of my ball, remember, is still this rectangle right here, but if everything works with our collision mask, it should only fire this part when our actual ball is hitting the rectangle. But we're still going to use our rectangle to do a little bit of calculations here, and we're going to calculate what's called the delta x and the delta y. So the delta x is going to be, let me switch my pen color here. The delta x is going to be the overlap of these two things. It's going to be where those x's overlap. How much do they overlap? And the delta y is going to be the same thing on the y-axis. We're going to say, okay, how much do these overlap? And the reason we want to do this is we want to see if there's more x overlapping, then I can say it's probably hitting from the left-hand side or the right-hand side. I can say, okay, it's hitting here because there's more of an overlap on the x, whereas there's less of an overlap right here. So I'm going to call this a right-hand collision. And what we'll do too is we'll make some accommodation. If they're in a little range right here, we'll call it the corner, and we'll just reflect it back the way it came. So these delta values are going to be very useful for us to see where that collision is occurring, on which side of the rectangle it's occurring, without necessarily, having to know the exact point that it hit. So I don't need to know the exact coordinate it hit it and check that. I can just see how much overlap there is, and then use that overlap to determine what I want to do. So we're going to create some variables for that right now called delta x and delta y. So let's create delta x, and we'll set it to 0 for right now, and delta y, and set that to 0 as well. So the first thing I want to see is which way is the ball going, because I know if the ball is going to the right, I can't hit the left side of a brick. So if it's going to the right, I automatically know, excuse me, I can't hit the right side of a brick. If it's going to the right, I automatically know it's going to hit the left side of a brick. Conversely, if it's going to the left, I know it's going to hit the right side of the brick. Same thing with up and down. I know if my ball's going down, it will not hit the bottom of a brick, and if it's going up, I know it won't hit the top of a brick. So what we're going to do is we're just going to check that first, and we're going to say if the velocity on the x-axis is greater than 0, so going to the right, then I know I'm impacting the left-hand side of my brick. So I'm going to say delta x is equal to, and then we have to calculate that overlap. So the right side of the rectangle minus the left side of the brick. And that'll give us our delta x. Instead, if our velocity is going the other way, then we're just going to do the opposite. If it's greater than 0, then we say the delta x is equal to the brick's right side minus the ball's left side. So we have our delta x calculated. We're going to do the same thing for y. So we'll say if the velocity of, and I should make sure, I apologize, I should make sure I check the velocity of x up here. I did skip that step. So if the velocity of y is greater than 0, then we know that our delta y, we know it's going down, right? So then we know our delta y will be the self.rect.bottom, which is the bottom of the ball, minus the brick.rect.top, and it'll give us the overlap between those on the top. And if it's going the other way, self.velocity.y less than 0, so we're going up, then the delta y we have to check on the bottom. So we'll say delta y is equal to the brick.rect.bottom minus the ball.rect.top. So we'll check that overlap. Now, for any reason, if we hit the corner, you can mess around with these values. It's hard to test this one unless we add some debugging in there to like actually shoot the ball where we want it. But I'm just going to say if the delta x minus the delta y, and I don't really care if it's positive or negative, so I'm just going to do the absolute value of those. So if the absolute value of x minus y is less than 5, or you could do 10 or something like that, it doesn't really matter. If it's hitting in that corner is basically what we're saying. If they're both within that range, then we're just going to say that's a corner hit, and we're going to reflect what we're doing. So this is where we use our reflection again. We're going to say self.velocity.reflect in place, and we're going to give it a new set of coordinates to go towards. So we're going to take its own velocity, and this is a corner hit, remember, and let's make a note of that. We're going to take its own velocity on the y-axis, and we're going to flip it by, on the x-axis first, and flip it by multiplying it by -1. We're going to do the same thing with that velocity on the y-axis. We're going to multiply it by -1 as well. So we're flipping both of them. That means it's just going to come right back to where we sent it. If instead the delta x is bigger than the delta y, then we know that we have to flip our y value. The x value can stay the same, but we're going to flip our y value. So that's going to be self.velocity.reflect IP, and then we'll put a tuple in here, which is 0 for the x because we're not reflecting the x, but we'll reflect the y, so we'll just take our own velocity and change it to be the opposite by multiplying it by -1. So that means, let me say this, that means this is a left or right hit. And then the last one would be the top or bottom hit, where there's more overlap on the top than there is on the side, or the bottom than there is on the side. So we'll say self dot, oops, I have to put my else if in here. Else if the delta x is less than the delta y, then our velocity needs to be reflected along the x-axis. So we'll take our current velocity, self.velocity.x, we'll multiply it by -1, and we won't do anything to the y-axis. So if everything's all working with that, when we run this again, what we should see is that the ball is going to bounce off there. Now, that was a little worrisome, how it, if you saw how it killed that ball right away. That means that there were 2 hits that registered there. So we'll see if we can maybe recreate that. But for the most part, it looks like it's working. And I'm trying to think why that, why it might have done it for that one. And I could go back in the recording and look, but I'm wondering if our 10 is too big of a value for the corner. Maybe we need to lessen that down. And I think that that was really quick there. So it's not going to be perfect, and I'll say that right now. We're going to find bugs along the way, but this is how you would start it up. So yeah, you see right there, it hit those corners, and it reflected, and it hit the corner again. So maybe we try lessening this. Let's go back to our ball right here. Maybe we try lessening this value right here to something like corner hits like very precise, like a 3, if there's a 3 pixel difference. I'm just going to run it again and see if that improves anything or doesn't improve anything. But we'll see here. So that maybe needs a little bit of improvement there. There it didn't hit the corner. There it didn't hit the corner. There it did not. Okay. So let's just kind of go over what we have, see if there's any other spots where we can maybe polish it up a little bit, make it look a little bit better. So we have our main program. And we've worked with collision here. Now, like we just saw, the collision isn't necessarily perfect. There are some workarounds that we could do to make it a little bit better. Like if it starts colliding, we can turn a value on that says, hey, we're colliding. Don't collide again until we're done colliding, in case there's 2 frames where it registers as a collision, which could happen, right? It could register as a collision in 2 frames in a row, which is why it's going away 2 frames in a row. Or it could have a very, very small bounce too. We're not going to worry about those little double hits for right now. So if that happens in your game, just don't worry about it. But we have the collision detection here. We have our updates, all our sprite groups. So we have a halfway decent breakaway game. So what I'd like you to do is start thinking about improvements that you would want to make on this. And in the assignment description, you're going to see that I do have a list of there, did it again. A list of improvements I would like you to choose from. So go ahead and take a look at those and see, what looks good to you. What do you want to try to improve upon? Could be, and think of anything else you might want to add to this too. So could it be adding points to this somehow, adding whatever you want. So go through that, look at the list of improvements, think about how you want to improve on this, and then we'll take a look at what you come up with, and I have high hopes for y'all. So that's our breakaway game in a nutshell. All right, I was just playing around with it. I think the issue, fingers crossed, I lowered the gutter width, but I don't think that was my issue. I think my issue was because I was testing things out before. I had the frame rate set at 600 still, which means that the distance that the ball could travel is very, very minuscule in the amount of time per frame, right? Because we have 600 frames per second. So what was happening is it wasn't even traveling off the ball quick enough, and it was colliding twice. So I lowered the frame rate back to 60, and it seems to be working just fine now. So I think that was the issue. Just double check and make sure that your frame rate is 60 and not 600 or something crazy, because that gets a little bit too fast. So again, we still would probably want to code in something to make sure that doesn't happen. But again, I'm not really worried about that, especially if that was just the frame rate being 10 times too high for this. So don't worry about that. Just make sure your frame rate is within reason, which is like 60 to 144, something like that.